So without further ado, why don't we go ahead and have all of the panelists go around and introduce yourselves. Why don't I, just for the sake of everyone not accidentally interrupting each other, I will just say your company and then you can go ahead and introduce yourself. So let's start off with General Motors.
Yeah, this is Aaron Gofton. I'm from General Motors. Obviously, you just said that. And I'm the engineering group manager for full speed range adaptive cruise control, object fusion, and long range radar sensor performance, calibration, and development.
Thank you. I think there was one other gentleman that was supposed to be with you. No?
I'm not sure he has made it.
Okay. Okay, well then we'll move on. Intel, why don't you go ahead and introduce yourself?
Hi, I am Jacob Krakauer. I'm a systems engineer at Intel with the ATI group, Autonomous Transportation Infrastructure group at Intel, and been there for roughly 3 years now.
Great, thank you. Next, we have MathWorks.
Hey everyone, I'm Akshara. I'm the technical evangelist for SAE Autodrive. I recently joined the company. It's my second month, I believe.
Oh, well, that's great. Welcome.
Thank you.
And I'm Lauren Tabalinsky. I'm the student competition program manager for all our competitions that we support. We support about 50 different competitions around the world.
Awesome. Let's see. Next we have, well, Jamie, did you say that OXTS is not on the line yet?
Correct.
Okay, so we will go ahead to Siemens.
Hi, Lee Anderson here. I'm the worldwide director for student competitions at the university level. We have another program for kind of the STEM K through 12. And we support about 25 competitions around the world, including, of course, Autodrive Challenge. And I guess our kind of main offering there is the pre-scan autonomous simulator. Prasanna?
Great. Well, thanks, everyone.
Hi, this is Prasanna. I'm application support engineer at Siemens. I support customers using pre-scan and Marimo tool across North America.
Perfect. Now, did I miss anyone? Did anyone jump on from any other group yet? Okay, well then let's just keep going in the interest of time. So I do actually have one specific question for General Motors, and we'll just kick off with that one. Can you tell us a little bit about the landscape of General Motors careers?
Yeah, certainly. So right now, obviously a big focus at General Motors is our EV AV future, which, I would say ties in with a lot of the interests of folks participating in Autodrive. And, one of the big reasons that we're a supporter of Autodrive. And right now, that's where a lot of the opportunity lies at General Motors. Taking all of the aspects of automated driving technology, autonomous features, autonomous vehicles, combining that with our traditional vehicle architectures and our electric vehicle architectures, and using that as a platform to bring that technology to our customers. So exciting times at General Motors. All the things that come along with major industrial execution of high tech things, right? So we have everything from IT supporting our engineers doing the work, developing the software, calibrating the algorithms that are produced by the software teams, and then delivering really cool features and technology content to our customers. So really all aspects of those pieces of our business. So there's lots of opportunity, all the way from really the entry level of that, all the way through, even more experienced folks, and then, a whole wealth of opportunity with the bandwidth that a large company like General Motors offers. So. So I think I answered the question. Let me know if I didn't. So.
No, absolutely. Do any students have any questions related to that? Okay, we'll just keep moving down the line. So why don't we ask, I'm just going to go in the order that I had you guys introduce yourselves. So Intel, why don't you tell us a little bit about when in your career did you realize you were making an impact to the industry or your company?
So out of a lot of the folks on the call, I'm probably the youngest at 25. So I've only actually been in, post-college employment for about 3 years now. So for me, I quickly realized, once I got into Intel and, there's a lot of these customer facing problems where, it's not necessarily Intel knows the answer or the customer knew the answer. It was like we had to work together to find the answer. And, situations like that where, hey, we just solved a problem that enabled this customer to not only, be successful with their own, product, but also add a new capability to their customers that, at least in my aspect, providing safety features to a vehicle. So, and in this increasingly more automated future, the more features you bring, the more closer we get to that autonomous future. So granted, I had a very small part to play, but, we're all trying to figure out all these little technical, glitches / hiccups in order to make sure it's ironed out so that every customer, be it, a development partner or an end-to-end customer, has something that is not only fully, enabled, but also, safe to the highest order.
Very cool. Anybody else have any other thoughts about that? Any other, advice or feedback on making an impact to this industry, especially at a time like this with autonomous vehicles? No? Well, you can come back to that. I know this is kind of like an interview. I'm putting you very much on the spot. So if you think of something later.
Hi, Amanda. This is Aaron. Sorry, I was slow on my mute button. I'll say
Oh, no worries.
one of the really great things right now about all of this is that a lot of what we do, like in the automotive industry, is very well defined and traditionally well vetted, architected. We understand how to do it, right? So if you look at things like vehicle dynamics, we've been doing that for probably almost 100 years. You look at what we're doing now in EV, AV, that type of stuff. It's really decades or less that we've been working on all of those things, and so the opportunity for innovation and invention is just everywhere, and it's super exciting. To add that, and I'm sure all of the other sponsors are experiencing that same part of this.
I'll chime in with a suggestion, Lee with Siemens here, that I think for somebody who wants to go into autonomous engineering, the core competency that cuts across all of the things you might want to work on is being very familiar with simulation. So having that core skill, I think, is really central.
That's great. Thank you. And again, if we can at the end, if anybody has any other things that they want to just add on, we can leave some time for that. So let's go to MathWorks. How did you kind of arrive at this point in your career? Is there some advice about the steps that you took to get to where you are? And also, and maybe everyone could kind of answer this too once MathWorks goes, but are any of you alumni of a CDS program?
Interestingly enough, I was a student competitions participant. I was in the EcoCar Mobility Challenge, which was also a collegiate design competition, which is held by Argonne National Labs and Department of Energy. I was the Connected and Automated Vehicles Tech Lead, which is basically everything that the SAE Autodrive Tech Leads do. but there was only one of me doing it for my team. And so interestingly enough, I was in the competition for 2 years. I did attend a few of the networking events through the competition, and that is where I met my MathWorks team. I got introduced to them, and then I had an interview, and I got an offer from them. So I guess I would owe the beginning of my career to my student competitions experience, and it was a pretty grueling and amazing experience, if I do say so myself. In hindsight, it turned out to be a really good experience. It was my first foray into the world of automated driving. I had, especially with a very practical application, beginning from designing and choosing our sensor suite to figuring out where to place our sensors, figuring out which FOV sensors we have to choose, and then actually simulating them using MATLAB and Simulink, and then going on to verify those simulations, doing software in the loop simulations and model in the loop simulations, and then finally getting the algorithm that I wrote on a vehicle and then seeing it actually work. I think that was one of the happiest moments of my life, even though there was a lot of trial and error going on. But when it actually finally, I was actually able to. So I worked on the sensor fusion algorithm and sensor fusion and perception system algorithms. And when I actually saw a vehicle detect another vehicle in front of it in our visualization tool, I think that was one of the happiest moments of my life.
Oh, that's awesome. And it just, that's what's so great about these competitions, is that any hard work that you put in just really pays off. So that's fantastic. Anyone else want to chime in?
I'll just add, Akshara, I met her at the competition, and I have a whole team of engineers who works on different competitions. And it was just a perfect example of why you want to do this type of stuff, because it helps you get these great jobs at really good companies. And I would, probably never have met Akshara if MathWorks wasn't involved, in that competition. It's not Akshara. What she does is not an easy type of engineer to find. As Jacob, I think, said in the beginning, like it's more traditional automotive engineering. Or Aaron, sorry, I think said this. It's just like she's a different type of automotive engineer that we're starting to see more and more of. So we're hoping to find more people like Akshara through what we do here.
Yeah. That's fantastic. And I think just even goes to show why these challenges are so important. And in particular, this Autodrive one, with it being such a new and very much like a creative, and you have to have the right kind of problem solving skills for this type of challenge. So that's fantastic. Let's move on, just in the interest of time, to another question. And did anyone from OXTS ever join us? Eric or Jamie? Okay, so I will then go to Siemens, and let's see. What product that you can speak about are you most excited about, or do you think will have a big impact on the industry?
Well, that's actually kind of a challenging question, because we have such a broad array of products. So it's almost more that we have such a comprehensive integrated product suite across electrical, mechanical, autonomous development, manufacturing, product data management, and it all works together. So we're really the only technical software company that has that much breadth and best-in-class tools. And but relative to this competition, yeah, as I mentioned, it's really the pre-scan autonomous simulator, the wire harness tool called Visys, along with Capital, which is a GM standard tool. And we also have some circuit board design tools, which are GM standard, and a lot of other tools. As I mentioned, it's almost more that we have such a comprehensive suite that's all integrated, as well as most of them being #1 market share and/or best-in-class tools functionally.
Okay. Great. Is there, before I was just going to ask a few more questions, and whoever wants to respond to them can just jump right in, but is there anything that anyone, is dying to just mention or talk about before I ask any other questions? Any students? I don't see anything on the chat, guys, so if there are questions from the students, go ahead and send them through the chat. All right, I'm just gonna, oh, do I hear somebody?
I did. So this is Allison Amanda.
Hey, Allison.
Hello. I just wanted to put out to the panel that has been involved with us, and a lot of our speakers have been with us over the years. And so what have you kind of looked forward to every year at the Autodrive competition? And are there different things that maybe we do that you've implemented or taken back to other student competitions that you participate in? And just kind of the engagement with SA International and General Motors in this. As Amanda said, this is a different technology. It's a little bit of a different program than we've done here at SA International. It's different than a Baja or Formula. And so, what kind of nuances or different things do you appreciate or you enjoy coming out from the Autodrive Challenge? Or is it teams on site and just the working relation?
Allison, I could speak to that real quick. I think for us, you are doing some cutting edge stuff that's new and different. And we think it's a great place for MathWorks, to learn from students, what we need to do to make our products better. Oftentimes we'll be working with the team and they'll be like, we're stuck, and we take that feedback back to our development team, and, we work to improve things. And we actually have a large group of people that work on this at MathWorks outside of Actura. We have mentors that have been in industry before and things like that. So just the whole setup of it, we want to help students, but we also really want to learn from the students themselves, because they're doing things that maybe we're not even thinking about. So that's one of the main reasons that we are involved in this.
I actually had the ability to sit in on a few of the simulation challenge reviews, and definitely from your team, I would have people like Mark say, I've never thought of using it this way or adding something different. So that was really nice to hear from the team.
So I'll echo, what Lauren was saying. This is a two-way street in the whole learning aspect, right? Automotive is, necessarily a new thing. It's been around for hundreds of years, but automating it has been, a challenge for everyone. Learning how all these changes are, taking place, from the workloads to the technology required. So at least on our side, we've been really appreciative of, like, every time, something difficult comes up, the students let us know, because, granted, they may not be immediately a customer, but they're going to soon eventually enter the workforce and hopefully be one of Intel's customers. We're finding that, what may be easy for ourselves internally may not come easy to others. So it's allowing us to see where our own gaps are in, educating, those, outside of Intel, how to use our technology, as well as us learning how we need to improve to better serve, the students as well as customers, using our technology and working with others and their technology.
And I think it's really exciting that all the students are working on solving the same problems that we're trying to solve in industry, right? And so it's one of those things that a lot of the stuff that is being worked through and worked on are the same things we're having challenges with in the real industry execution of the same technologies.
Well, speaking of the challenges, what do you guys think, as autonomy continues to advance, what problems do you think are going to arise when it becomes more widely accepted? Anyone want to take a stab at that?
To be honest, it's always going to be that 1% or 99th percentile event. That's always going to be the hardest challenge for anyone's solution, regardless who makes it or how well it's accepted. Today we're all focusing on the worst case, but we don't necessarily know what that's going to mean in the future. The one freak situation. So being as proactive as we can and, either simulate or test every possible thing, writing standards on, what we can all agree on so we can at least have some group, accountability that we're all trying to put in our best foot forward is definitely something in the future that we all are contending with.
That's a great answer. Anyone else want to talk about that?
Well, I think it's probably accepted wisdom, but just the point that on-road physical testing of autonomous is certainly vital and important, but it's essentially impossible to do enough on-road physical testing to achieve a high enough confidence for autonomous algorithms and sensor suites and fusion and all that to be safe enough and functional enough. So again, goes back to my comment that autonomous simulation is a core skill and an absolute requirement, and billions of miles of it to be commercially viable, many billions of miles.
Yeah, especially when it comes to edge cases, environmental edge cases, as well as target vehicle edge cases and fail safes and things like that, right?
Yeah, like having a white semi-trailer tipped on its side in the middle of a freeway with a bright sun behind it.
Right, or a snowmobile trailer covered in mud with a sideways license plate even, right? Those kind of things.
Sounds like a couple of
really
examples that someone may have experienced lately and additional test cases out there.
Yeah, the famous Florida incident with the tipped over semi-trailer and Tesla.
I think that, I don't know if this is a challenge so much, Amanda, as just a perception. When people talk about autonomous vehicles, you think San Francisco or, Phoenix and, these large metropolis, cities. And so there's a great deal of population that lives, where I do, in small towns, USA. And it's like, well, how does these autonomous vehicles affect, us, right? And I think, it's a similar approach when we talk to students. It's like they want to come out of school and work in autonomous. And I explain to them that, that's really the tip of the iceberg. That's the ultimate goal. But all that they work on and the technologies that are developed and the stepping stones to get there, we can spread that technology across many more vehicles that, customers day-to-day drive, all of our active safety features that get into, our vehicles, mom and dad's vehicles, our children's vehicles, that makes everybody safer. It's that technology suite that comes from developing autonomous is really, in my opinion, just as large or larger of a contribution to, society. So, explaining that to students is one thing because we want to work on autonomous, but when people hear autonomy of vehicles, there's so many different levels, right? And explaining, like the SAE standard of, autonomy. And that kind of breaks it down, and that's a way to talk to your neighbor about it. So that's, it's what I see day to day talking to people that aren't familiar in this technology space that we are.
Yeah,
That's
Kevin.
the total. Oh, who's that?
Me, it's Allison.
Oh, hey, Allison.
Kevin, you bring up a great point about the connectivity and kind of the web of systems that comes together and teaching active safety and different things. And I think the group that we've assembled here and a lot of our suppliers and sponsors, safety is something I've definitely heard across the board from everybody in this new technology, but it's really building, what does that ecosystem look like? And so it's piecing all of these things together, especially in a program like this, where you're able to take a lot of the different technologies and hardware and software, and you're really putting them together to hit that goal. The goal, obviously for our students is to be able to do the competition and their dynamic challenges, but we've put in things along the way about safety and about different social responsibilities, so we're getting them to really understand that full picture and not just one piece of it.
Mm-hmm. And in terms of a challenge, I'll go back to the technical challenges. Reason that I'm late coming to this discussion, and I apologize for chiming in late, is a neighbor's house just caught fire. And so I'm finishing up our previous session. I'm hearing all the sirens and commotion, so I go outside to find the neighborhood filled with ambulances, trucks, traffic of people that are gawking, and all the commotion going on. And you think about those situations with autonomous vehicles anywhere. It's like, oh, okay, just grind to a halt, right? It's just totally random and overwhelming, to an area. Yeah, that to me would be a huge autonomous challenge.
Yeah.
And it was very distracting to me too. I mean, I was just like, what the heck? It's like there's a house burning next door and 2 cars just blew up in their garage.
Oh my gosh.
Yeah,
There's more people.
That was the neighbor. Yeah, that was the neighbor just a few minutes ago. But everybody's safe. But you throw that kind of chaos into an autonomous situation, it's okay, game over. How do you get out of it?
Right. Oh my. Well, anyone else want to chime in on that, or I can ask another question?
Well, I've got a point to make about engineering methodology, and part of this is informed by being around different software development groups, which is, of course, the core of the discipline that autonomous development has to be based around, because it's very algorithm heavy. And I made the point about simulation and having to validate not just physical but simulation. But the other point is, and this is something it's been a signature of every very successful software group I've been involved with, is that they have very rigorous regression testing. So that means not just using testing to develop, but when you say make a change to the algorithm, that you need to be able to run a robust suite of tests to validate just that new change. So it's not only about developing moving forward, but it's making sure you don't break things. So that's one aspect of the process methodology that I wanted to highlight.
Certainly, that makes sense to me, and I'm not an engineer, so. Okay. Let me just check and see if we have any questions. We don't yet. So I will just ask another question of all of you. So, oh, I like this one. So when autonomous vehicles first came to the table, what was the reaction in your company?
I can take a stab at this. It's actually kind of funny. Self-driving cars was actually a little research project out of our Internet of Things group, almost 15 years ago. We were just driving around the parking lot trying to figure things off. And then, you first, hear wind of this, and then we have customers coming and saying like, hey, we don't really know how this computer thing works. And they're like, oh shoot, maybe we should make something that does this, a little more than just a science project. And then the autonomous driving group is now born. And it's since changed names and now is called ATI. But largely it was just a bunch of engineers, some new to the company, some veterans, who are just like, hey, this is something cool. I've seen enough sci-fi movies. Let's just put a giant, server rack in the back of a trunk and see if we can make the car move. Ross, granted, it's not, the solution for your end goal of a self-driving car, but you can get something rough and dirty, fairly quick, for that, science project level, engagement. And then, from there, you have your launch point, adding, the layer cake of features and considerations and safety. And, everyone's got their, 10, 15 year development story where, it kind of all started from something similar like that, I would imagine.
Good stuff.
Yeah, I guess I'll chime in from Siemens. So I guess about a similar time frame, several years ago, we saw that the autonomous was going to be a significant technology trend. So besides the things I've mentioned, like the pre-scan simulator, we actually developed a complete software stack based on the AUTOSAR standard which I don't think the students are very familiar with, but it's a layered embedded architecture for ECUs in vehicles. So we've got an entire AutoSAR stack and in-vehicle software stack for both autonomous and connected, V2X, V2V, that sort of thing. And plus, we even have developed a chip so to do sensor fusion and whatnot. So there's actually a complete hardware software solution that we offer. It's a bit too complex for Autodrive challenge teams to take on that whole technology stack, but we do have take up in the car maker community. So yeah, we saw it and said, yeah, we gotta invest.
I'd like to say that I'd like to say that I knew how, or know when our General Motors first thought, okay, let's get into this game. I don't really am at the level of having the insight of the boardroom discussions and, our senior level management that said, okay, yep, it's time to go. We, have been working in innovation for quite a while. I worked on the Gen 1 and the Gen 2 Volt and electrification. When I moved over into that area, it was, oh, Kevin, why are you moving into electrification? That's going to be a dying thing. It was all the traditional internal combustion engine colleagues of mine were like, you're crazy. But that sense of innovation really took hold, and that same group of people that like-mindedly, generated the Volt Gen 1, Gen 2, the Bolt EV, the Spark, and even going back to EV1, the chief engineer of that same core group of people, once autonomous was announced that we're proceeding down that path, we're drawn into that organization. And they are really the ones that moved it forward. So I knew at that time, that gathering of people really meant that the company was serious about it. So, we then Cruise Automation, acquiring them, and getting them to be involved out of San Francisco and, Silicon Valley and all. That was also a big step. So
what do you do now, Kevin? What do you do now, Kevin?
This is it. This is my job. It's program manage the Autodrive Challenge competition, partnering with Allison. Her and I became co-partners here on creating this competition a number of years ago when one of our vice presidents and GM said, hey, this sounds like a cool idea. Let's talk to SAE and let's get this started. At that time, I was just finishing up working in the Gen 2 Volt. I was the assistant chief engineer of the propulsion system and said, hey, it's time to do something different, and totally different it was. Work on this collegiate competition and work with students and get it off the ground. So that's what I'm working on. I'm really enjoying talking to students and, interacting with all of your companies. And really what's the most rewarding for me right now is the student interactions and seeing what they can do and seeing the same sparks that they bring to, General Motors and hopefully to all your companies when they, exit a competition like this in school and come to work. So.
Well, kudos to you for helping start this thing. That's awesome.
Yeah, well, it's been fun. Lauren, you were there, in the early day too. So
Kevin and I kind of joke that we were handed a piece of paper and told to kind of build from this agreement to move forward. And along the way, we picked up a lot of different industries and people, and it's been such a rewarding experience. And it is. Lauren's been with us since the beginning. since we kind of started. Jacob has come in maybe a year into it and has been with us. And Lee is just now in our, I think, second or third year kind of joining. OXTS has been with us, and it's really become a community that we've built. And I think that's one of the most proud moments of working at SAE, and to be able to partner through General Motors to allow us to do a competition like this.
Yeah, it's been awesome to see the evolution over the years, and even at MathWorks, when we first got involved in this, we were like, wow, what are we signing up for? And we've just learned so much, and we're able to do a lot more. And I think, we saw some really nice results in the simulation challenge this year, and we're continuing to evolve that. And it's just really inspiring every day to see this. And I agree with Kevin, like working with the students is amazing. And then over time, as I've built out a team to support these, I've gotten to hire them. And that's even cooler because I have something to offer them when I meet them. And I'm like, we need to get this person at MathWorks. So it's really good.
Well, it looks like you were successful with the person on the left here.
Yeah, sometimes
Akshra, that's amazing.
GM and MathWorks will fight over somebody.
Oh, that tells you what kind of caliber students that come out of these competitions.
Yeah.
Well, guys, we have 6 minutes left. So, just wanted to do a time check and also ask any of the students out there, do you have any questions for the group at this point? Or does the group have anything that you guys want to talk about? Like I said earlier, any like burning things that you wanted to bring up or discuss?
I would love to hear a question from a student.
I know. I don't have any. Come on, students.
Listen, I have a free long sleeve t-shirt for the first person who asks a question. Raise your hand and we will allow you to talk.
There you go.
Ooh. Nobody.
I like your giveaways. I'll let no.
Yeah, I was going to say, if I could raise my hand, Jamie, what did you have for lunch today?
Yeah.
Wait a minute, let me guess. It was guacamole and crackers. Yes.
Yeah.
Guacamole. Okay, well, let's do this. Maybe this will get the students to think through some things. If you could all just go around and tell them, what's one piece of advice or one takeaway that you would want them to have, regarding getting into this type of career or this technology, or just any general advice.
Just that all the sleepless nights will pay off eventually. So continue doing that.
I'll make a comment that if you find one category of engineering software that you just absolutely fall in love with, whether it's, circuit board design or pre-scan autonomous simulation, there are actually career paths in doing that. Prasanna on our team is basically a customer consultant. So she helps our customers, figure out some tough problems with a tool. So that's a career path.
I would say your teamwork that you're doing and working through issues and different parts of your car is going to help you so much when you go into the workforce, to just be able to collaborate quickly and work on group projects. Because once you go into the corporate world, there's a lot of people that need to agree on things to make things happen. And, I find that students were part of competitions, have a head start by sometimes 10 years over other people is what I think when I see it. So that's my big thing. So keep working, and this is so worth it, and put it on your resume that you did this. Sometimes people will have a resume and it doesn't have anything on it, and I'll talk to them because I saw something else on the resume, and then they'll start talking about a competition they were in, and it changes things a lot. So make sure you highlight your work that you're doing in this competition on your resume.
Yeah, and my biggest piece of advice is that don't be afraid of problems, because that's why we all exist in the industry, is because it's hard. And so when you run into things and they break, one of the reasons that you get hired into industry is to fix the broken stuff. So embrace that. Don't be afraid of it. That's kind of one of my biggest lessons learned as I've gone through my career.
Yep. So, my little tidbit is to never stop learning. You're going to learn, some basic stuff, in college, and then you're going to go in the real world and you're going to find that, one, you're not the smartest person in the room. And then two, you can never stop learning because all this stuff is moving so quick. You're going to learn so much the moment you get into industry, just because we're moving so fast. There's new technology becoming available. There's new problems to solve that no one's figured out yet. And be honest, there's going to be a lot of different opinions in the room, and even if yours doesn't agree with another, it's still another opinion that could be just equally as valuable to a discussion or a solution. So, going back to Lauren's point about teamwork, having the mentality that, it's a group effort, it absolutely is, and everyone's got to do their part.
That is too bad that no one took Jamie up on her offer of the shirt. However, I think that was a really great way, guys, to just sort of round things out and conclude everything. Like I said, to the students out there, if you didn't feel like asking a question right now, please, you can send me an email and I can actually type that in the chat.